For the morning roundup, we have a Mark Twain here. He's turned out quite well. He also has a front side. A classic saber-tooth skull with base. A mech and an otter. Mercifully, the D20 is very close to done, as is the coffee cup. The coffee cup lid is printing like a champ, but we still have problems with these two. So this one I thought was kind of fine, so I didn't swap out the hot end because it just, the last thing it did, I thought it had a layer shift. But this one, man, this is just the worst. This is an entirely new hot end, and it's doing the same thing it was doing. And this is different filament. I guess I'm going to swap out this extruder motor. It doesn't really make sense because that's working fine. I guess I'm also going to make sure this extruder assembly is put together correctly because it looks like it might not be. Like the wheel might not quite be in the right place or something. Let's hope that's what it is. Plus there's a lot of plastic buildup there. Maybe cleaning that out will help. Perhaps best of all though, the brand new S5, new to me at least, is working really well. Like everything about it, except this crazy screen. It's giving me like one of the levels from Sonic. I think that's Sonic 2. The horrors persist, but so do I. I'm gonna need some bops for this one. You may remember at the end of the last video that this thing broke. I don't think, yeah, we don't have the new motor, but we have the old new motor. So that's what we're going to replace it with, because even though that motor wasn't working that well, it's gonna work better than this. Cue that one monologue from Agent Smith in The Matrix. I want to be rid of you. You are disease. I want to be free. I'm not really going to document the whole thing since I've done this a bunch of times already, but disconnecting these wires, taking it out of the housing, doing the whole thing. If any of you, for some reason, need to do this, there's a whole instructional video that I did. I'm pretty sure it's the only instructional video of its kind on the internet. And I say that because I would have loved to have watched that instructional video before learning how to do this. One day before retirement. All right, so I kind of randomly had to go to Lufkin for something, so we are going to Goodwill. Sadly, not my size. Sadly, not my size. This dressing room has no curtain. Tank tops were a no-go, but this is the perfect hat. I think we're just gonna get some coffee and head back to the shop. Getting Lufkin Duncan. I'm not sure I'm ready for something this exotic. Man, the Lufkin Duncan is taking a lot longer. It's actually really hot out today. This is gonna feel good. Okay, so we have a pretty significant problem with this thing. Everything was going good, but for some reason, on all three of the FILABOT units I've had, the temperature controller has just stopped working. Now this seems like, well, the obvious solution would be to buy another one of these off of Amazon, which I could do, but I don't have time to wait for that. Plus, they keep going bad. So, I'm trying to think creatively, and what I've concluded, I mean, we haven't done the tests yet, okay? But I believe I can heat up the barrel that you extrude the filament through using a 3D printer box. The reason being is here. This heated barrel that the plastic gets pushed through has three things coming out of it. And 3D printer people will recognize it has these two wires which are heating wires basically. And it has this third one, which terminates into 2 clips. What does this remind you of? Tick tock, tick tock. This is just like a hot end, as in like the hot end that you push the plastic filament through on a 3D printer. So what I'm thinking, and I'm gonna read up a little bit and see if this seems to be true and then do a test. We can hook this up like a hot end on a 3D printer. So there's a couple things we got to do. First off, there are different kinds of thermistors, as in the thing that detects the temperature for anyone that doesn't know. So we need to make sure that the kind of thermistor that the 3D printer control box uses is the same that the FILABOT unit was using. And one way we can verify this is by hooking it up and seeing if it gets a normal room temperature reaction. I guess something that's worth saying is the reason it would be good if you can do this is because like these kind of parts and stuff, I don't know how to use, or I haven't done that much stuff with, but everything with a 3D printer is something I've messed with many times before and understand very well. So if we can extrude filament using normal 3D printer stuff, then it's gonna be really easy. Like I could make a whole bunch of filament extrusion machines if we could just use ordinary parts and stuff. Okay, I've hooked up a normal hot end. This is a kind of messed up hot end, but the parts should work. And you can see that's giving a pretty normal room temperature. I actually heated up this hot end with a heat gun a little bit just to make sure the temperature would move, and it has. And so that means this thermistor is working properly. What we're also gonna want to do is heat this up via the heating wires a little bit, just to make sure that it's all connected and stuff. So we're gonna preheat it, and if this starts going up, I would say 5 degrees, then it works. 30, 32, yep, all right, that's working. One objection you could, we're about to do the thing, but one objection you could rationally have is like, how would a box like this that's made to heat up something this small heat up something this big? Which seems like a good point until you realize the power supply of both is the same. They're both 500 watt power supplies, or at least technically a CR10 comes with a 350 watt power supply, but I have 500 watt power supplies I can install in it. So if the power supply is the same, I mean, the heating is gonna be similar. Like, I don't see how it would be different. All right, just cut these. We're gonna spread these out and connect them to that one and see what happens. So like I said before, this is the thermistor wire from the heating barrel. You can see it's got 2 things. We're just gonna pull these plugs off, and there's gonna be wire underneath, and we're gonna interlace the wires with these 2 splits, and it should work. So the temperature reading is very weird. This is room temperature, and it's reading it at 300 some degrees. But what I think I can do is just install a normal 3D printer thermistor in the barrel. This is the thermistor connection. There's probably some way to put a normal 3D printer thermistor in here. Okay, so we're gonna put a thermistor through this, a normal 3D printing thermistor, and I think that should give us a pretty accurate reading of the barrel. Goes just like that, and hopefully that can heat it. We have the thermistor from a normal 3D printing hot end installed, and hopefully that will be accurate. And we have the 2 heating wires. So now we just have to turn this on, and this is going to be the moment of truth. And all we got to do is preheat this like we would preheat a hot end, We're getting a temperature reading of 24. Let's see if it will let us do this. Wow, here we go. It's much larger, so it should take longer. But we'll give this a bit and see what happens. Okay, this basically isn't working, but I'm thinking it might be because I'm trying to power it through the nozzle output, and maybe the heated bed would do better. I mean, this actually is working, well, it was working very slowly, but I think I'm on the right track. I think it's just gotta be the heated bed. All right, so none of that stuff worked. It barely worked. Like, it would make the barrel heat up a little bit, but it wasn't really working well enough. There just wasn't enough power going into it. And I think I've concluded that this is the thing that's wrong right here. For one thing, I ordered another one of those temperature controllers, but I really need this to work now. So I asked AI about it, and there are maybe some things I could buy from Lowe's that would work. Late night run. So apparently you can just use a dimmer switch like you would get, you know, for an outlet or something, or for, you know, a light socket, and you can regulate power with that. So that will be our temperature control. It won't be able to intelligently adjust the temperature, as in, like, it won't be able to adjust itself, but if it gets the same amount of power consistently, it should stay the same temperature, especially after a while. So it will probably work. This is where you're gonna plug in. This is the dimmer switch. The ground wire goes here. The hot wire goes here. One of the wires from the heated barrel is gonna connect to there. And then we are going to connect the other wire from the heated barrel to this black wire. So there's no reason why this shouldn't work, but I've said that a bunch of times before. Everything you want is on the other side of frustration. So as near as I can tell, this is set up like you would set up a light fixture or something. The yellow is the ground wire, that's what the green is for. Then this is the red power hot wire from the AC, which is not plugged in, of course. This goes here, and this is circuitously connected to the black, thus completing the circuit. We're gonna plug it in. We've got a thermal or an infrared thermometer, so we won't have to touch it to see how hot it is. This should get good and hot. So here we go. So I'm thinking I must have hooked up the dimmer switch wrong. So to test that, I've connected the heating part, the heated barrel, directly to the wall power. So this should be getting hot, and it is. It is getting hot. Okay, so there's something weird going on with the dimmer switch. I guess we'll have to figure that out. There may be some possibility that this is set up right. Let's see what the current temperature is. About 82-ish. I mean, it looks like it might be going up. This is not the most precise way to measure temperature, but after a good while, it should be noticeably hotter. The initial thing I read kind of had me setting this up the wrong way, but apparently this is the right way. So the power from the wall goes into one of these, I think specifically this one, and then the output goes on the black terminal. See, I won't explain what was confusing about that. It's not worth getting into. And the other one goes back to the wall, which completes the circuit. This was extremely frustrating, but I found a way to control the temperature using a common wall. Why is it so hard to, yeah, there we go. A common wall outlet, like a common wall light controller. That costs like a couple bucks. and that will control this. So to put this all together, I can control the temperature of the barrel using a $9 thing, and I can control the motor that pushes the plastic through a box from a 3D printer, both of which are things I have either ready access to or already have a bunch of. So what that means is I can extrude filament using extremely common items now. Also, I can use a thermistor from a normal 3D printer to monitor the temperature and adjust it with the dimmer switch. This was extremely frustrating, but like I just said, well, I said like an hour ago, but a couple minutes ago for you guys, all that you want is on the other side of frustration. With this discovery of the dimmer switch, the entire nightmare has come to end. I'm sorry that this has been a little boring, but this is a super important problem. It's a problem that in solving will cause my life to be so much easier. Here's how this is gonna work. We're using one box to monitor the temperature of the barrel. The reason is because we need a screen to read out and tell us what the temperature is, and the thermistor is going to be connected to it. We're gonna take these off. This is gonna be mounted on the wall up there somewhere. The second step is going to be to sort of put all this together like normal, except the heating element will be from here. We will be controlling the temperature by turning the dial, and once this is on the wall, we will know when we've turned the dial enough, we'll be able to dial it in and know that the temperature is gonna be correct. Once the temperature is correct, the power from this box will power the motor. This may look really stupid, and it kind of is stupid, but all of the parts that are going to be like making the filament maker work are things I have tons of and am used to working with. I mean, maybe with the exception of this dimmer switch, but it's a pretty basic thing. So even though it's sort of complicated, it's making this whole thing like much simpler in the long run, because I don't have all these fiddly parts that like I don't really know how to use them and don't have any experience with them. Everything in this setup will be like replaceable and reliable. I mean, I know how reliable like all these 3D printer parts are. So I'm taking something that's my hugest pain in the butt and making it easy. Longtime viewers will remember this part. This is the part that if you're doing it right, genocide starts to seem like a reasonable option. Basically, this entire power supply and a lot of this stuff isn't even necessary anymore, so I'm just taking it out. Probably wrap up these little cords and stuff, but this is a much more basic looking extruder at this point. I know this has been said, but instead of a company that sells you something that you can use for longer than 3 months, FILABOT sends you a $3,500 thing that breaks within a couple months, and you have to become basically an electrician to keep it working. Just think about that. Imagine starting a company and charging $3,500 for something that works for about 2 to 3 months, even if you're using it as directed. All of this stuff I had to learn to do, I don't have a background in any of it. I had to learn how to do this stuff, and I'm not even sure this is gonna work. I had to learn to do that just to keep this thing working. Let's remember this whole thing today was started because I needed to install this motor, but then all the other stuff stopped working. So I don't even know if this is gonna work. Last time this motor was in here, it was running too slowly. Now I figured out there were some problems that may have caused that, but I still don't know if this is actually gonna work. One ridiculous setup later, and we are about to see if this works. It's set up here like it was set up over there, so it should. It does look like we're getting liftoff. 26, 27, 28, 28, 28. We have placed the insulation again. enough of the nozzle sticking out, or there's going to be a nozzle there. All right, and it is heating up. We need this temperature to get to about 170, 180, really about 180. Put little arrows on there, red, less, green, more. This appears to be working. All we gotta do is put the speed controller back. We're gonna connect it there and with those, and I think we will, I feel nervous to even say this, a working filament setup. Time to test the motor, which initially was the whole point of what we were doing. And it's working pretty much awesomely. You know, it just dawned on me. The fewer FILABOT parts this thing has, the better it works. It says a lot. If something can be underneath, can it be overneath? Well, it's making good filament. It's staying at the right temperature, but it's really making a sound I don't love. It's really kind of not supposed to sound like that. But if it breaks, I'll fix it. Until then, screw it. All right, we might end it here. I just spent 14 hours straight trying to get that filament maker to work, and it's working but acting weird, which is a great feeling. Plus, I spent like the last 2 or 3 days trying to get it to work. So there's that. But I guess what I'm grateful for today is that I ended this day with a solution, whereas I could have just not. But I really, really needed to spend today packaging things and painting things, and I couldn't do that at all. But it could have been worse. Let me know in the comments what you're grateful for. Peace out.